The topic is the second derivative test to find extrema. Let C be a critical number. F has a relative minimum at x equals c if the second derivative, f second prime of c, is strictly bigger than 0. And in that case, the minimum is f of c. And then f has a relative max at x equals c if second derivative of f at x equals c is less than 0, and in that case the maximum is f of c. Alright, so, and if the second derivative is equal to 0, then the test fails. So first we need to find, so here's an example, f of x is equal 1 over 4 x to the 4th minus 2x squared. And we're supposed to use the second derivative test to find the extrema. So first we need to find critical numbers, right? So to find critical numbers, we always find the second of the first derivative and set it equal to 0 and then solve for x. So f prime of x is 4 times 1 over 4 x cubed minus 4x, which is equal x cubed minus 4. Now, to find the critical numbers, we set the derivative equal to 0, which means x cubed, minus 4x, which means x cubed minus 4x is equal to 0. To solve this, we need to factor the x. So x factor of x squared minus 4 is 0, which means x factor x squared minus 4, so it's x minus 2, x plus 2, and that's equal to 0. So the critical numbers are, so this means that x is equal to 0, or x minus 2 is 0, or x plus 2 is 0. So critical numbers are x equal 0, negative 2 from here, so negative 2, and then 0, and then 2. Right? So now we need to test them using the second derivative. So therefore we need the second derivative. The second derivative will be, where's the first derivative? First derivative is right here. This is f prime of x, so we need to take second derivative, so the derivative of the first derivative, which is 3x squared minus 4, right? Now, to test those critical numbers, if they're maximum, relative max, or min, we only need to do, is what we need to do, second derivative. We need to evaluate the second derivative at x equal negative 2. We need to evaluate second derivative as x equals 0. We need to evaluate the second derivative as x equals 2. Alright. So if you plug in negative 2 into the second derivative is right here. So this will be 3. Negative 2 squared minus 4. 4 times 3. 4 times 3 is 12. 12 minus 4 is 8. This is positive. Therefore, since it's positive, look here, therefore we have a relative min. So, relative min, we have a relative min at x equal negative 2. But what's the relative min? It's actually, look here, f of c. So f of negative 2. We still need to plug a negative 2 in there into our original function. So let's plug it in. And if you plug it in, you'll get negative 4. If you want to know how I did it, so you plug it into the original function. Let's just do it here. F of negative 2, if you plug it into the original function, this is 1 over 4, negative 2 to the 4th, minus 2, negative 2 squared. And this is 16 over 4, minus 2 times 4 is 8. And this is 4 minus 8, which is negative 4. So this is the relative min. Now, second derivative of 0, so we plug in into the second derivative right here. So it's 3 times 0 squared minus 4. It's negative 4. It's less than 0. Therefore, it's less than 0 right here. Look at the definition. That means we have a max. So relative max, which is equal to f of 0. If you plug 0 in the original function, you'll get a 0. I mean right here, f of 0, 1 over 4, 0 to the 4th, minus 2, 0 squared, which is 0. So this is a relative max. Now we do the same thing, plug in the second derivative, plug in 2 into the second derivative, you get 3, 2 squared minus 4. And this is exactly like the it has to be 8. It looks exactly, if you look at this one, it's exactly the same. So it has to be 8, which is positive. Therefore, we have a relative min, which is equal to f of 2. Now, f of 2 is equal to, if you do f of 2, 1 over 4, 2 to the 4th, minus 2 squared, and that's also equal negative 4. So negative 4, so this is our relative minimum. And that's it for this example.